Hi, everyone, and welcome. Today, we're diving into something that's like a core skill in any kind of chemistry work, calculating solution concentration. I know it might sound a bit technical, but don't worry. I promise we're going to make this super easy to understand. Let's get right into it. So, have you ever looked at a bottle of, say, saline solution and wondered, how do they know exactly how much salt is in there? How do they measure the amount with such perfect accuracy? Well, that's exactly the skill we're going to master today. All right, first things first, let's break down what a solution even is. It's actually super simple. Every solution has two main ingredients. You've got the solute, that's the stuff that gets dissolved, like the sugar you put in your tea. And then you have the solvent. That's the liquid doing the dissolving, which a lot of the time is just water. Mix the solute and the solvent together and boom, you've got your solution. See? Easy. Okay, so let's start with the absolute foundation. This is the simplest, most direct way to think about concentration, and everything else we learn today is going to build right on top of this. At its heart, concentration is really just this: how much stuff is in a certain amount of liquid. Or, more scientifically, it's weight divided by volume. We're just looking at how many grams of something are dissolved in a specific amount of solution. The standard unit you'll see for this is grams per liter, which we write as G/L. Okay, let's put this into practice with a real example. Let's say you need to make 300 milliliters of a solution, and the recipe calls for a concentration of 3 grams per liter. How much stuff do you weigh out? Well, step 1. We know what we're looking for, weight. The formula tells us weight is just concentration times volume. But weight, and this is super important, you gotta watch your units. The concentration is in grams per liter, but our volume is in milliliters. They have to match. So for step 3, we convert 300 milliliters into 0.3 liters. Now we're ready for step 4, the easy part. You just multiply 3 grams per liter by 0.3 liters, and you get your answer, 0.9 grams. Okay, that was the basic idea. But in a real lab, you often need to be way more precise, and that's where percentages come in. You're going to see these everywhere, so it's really important to get them down. So the first kind of percentage we're going to tackle is called weight/weight percent. We write it as percent W/W. All this means is you're measuring the mass, or weight, of the solute compared to the total mass of the whole solution. The thing to burn into your brain here is it's a weight compared to a weight. And the formula is pretty simple, actually. To get the percent WW, you just take the weight of your solute, divide it by the total weight of the solution, and then multiply by 100 to turn that decimal into a nice, clean percentage. So let's see how this works. Picture this. You've got a jar with 250 grams of a saltwater solution, and the label says it's 20%, W by W. So how much of that is actually salt? First, we just need to flip our formula around a bit to solve for the solute's weight. That gives us the percentage divided by 100 times the total weight of the solution. Then we just plug in our numbers. 20 divided by 100 is 0.20. Multiply that by 250 grams, and there's our answer. There are exactly 50 grams of salt in that jar. Next up, we have weight/volume percent, or percent W/V. Now pay attention because this one's a little different. Here, we're measuring the mass of the solute in grams, but we're comparing it to the total volume of the solution in milliliters. So this time, it's weight compared to volume. This one is incredibly common in medicine and biology labs. And here's the formula. It looks similar, right? But the key, and I mean the absolute key, is to remember the standard units here. The weight is always in grams and the volume is always in milliliters. Don't forget that. All right, time for another quick problem to make sure this sticks. How many grams of solute would you need to make 500 milliliters of a 10% W/V solution? We do the same thing as before, just rearrange the formula. The weight we need is our percentage, 10, divided by 100, multiplied by our volume of 500 milliliters. That gives us 0.10 times 500, which equals 50 grams. Simple as that. All right, we've handled the big stuff. But what about when you're measuring something that's barely even there? I'm talking microscopic amounts, like a single pollutant in a whole swimming pool. For that, we need to zoom way, way in and use units called parts per million and parts per billion. Take a look at that number, 1 million. When we talk about 1 part per million, or ppm, it literally means one tiny little piece of something in a million pieces of everything else. To really picture this, imagine one single drop of food coloring in a massive 13-gallon water cooler. It's that tiny of a measurement. So this table breaks it down perfectly. ppm is 1 in a million.
And then there's ppb, or parts per billion, which is even crazier. That's 1 part in a billion. But listen, nobody wants to calculate with numbers that big. So here's the shortcut, the pro tip that will make your life so much easier. For water solutions, 1 ppm is basically the same thing as 1 milligram per liter, or mg/L. And 1 ppb is the same as 1 microgram per liter, μg/L. Trust me, remembering that is a game changer.
Okay, let's use that awesome shortcut we just learned. Let's say we dissolve 0.0059 grams of salt in 750 milliliters of solution. What's its concentration in ppm? Well, since we know ppm is the same as mg per liter, the whole problem just becomes a unit conversion puzzle. First, we turn 0.0059 grams into 5.9 milligrams. Then, we turn 750 milliliters into 0.75 liters. Now, we just divide the milligrams by the liters. 5.9 divided by 0.75 gives us our answer, 7.87 ppm. And guess what? It's the exact same process for ppb, we're just using different units. So, what's the ppb of 9.6 times 10 to the negative 6 grams of salt in 2 liters of water? Well, our shortcut for ppb is micrograms per liter. So step 1, convert grams to micrograms. That gives us 9.6 micrograms. Our volume is already in liters, so we're good there. So we just divide 9.6 micrograms by 2 liters, and we get 4.8 ppb. See? It's all about that unit conversion. Phew, okay, you all did great. We have gone through a ton of information. So to wrap it all up and make sure you've got it locked in, let's do a quick review of the most important formulas. Think of this as your personal guide. Okay, here it is, your cheat sheet. Screenshot this, write it down, whatever you need to do. Remember, %WW is weight over weight times 100. %WV is weight in grams over volume in milliliters times 100. And for the really tiny amounts, remember the shortcuts. ppm is pretty much just milligrams per liter, and ppb is micrograms per liter. All right, so now you have the tools, you know the formulas, so my question for you is, which one are you going to go out and master first? Thanks for hanging out with me today. I'll catch you in the next one.